see me during break or something. If you want, we can talk about it. Just one more, except I'd like to show you how to use the calculator to do this. There's a built-in routine. Shall we do that? So an ABC News poll found that Americans now have relatively warm feelings towards Russia, a former adversary. The poll, conducted by telephone among a random sample of 1,043 adults, found that 647 of those sampled consider the two countries friends. Use this information to obtain a 95% confidence interval for the percentage of all Americans who consider the two countries friends. So here, again, let's just write down X and N. So X is going to be 647 and N is going to be 1043. So if we come over here to this guy, and again, if you come over here to stat and then arrow over here to test, all we have to do is take a look at menu option 5, single, no, that's the proportion test. So we need to scroll down to, there it is, single proportion Z interval. Okay, single proportion Z interval. So that's menu option A. So here, notice that it's just asking for three things: X, N, and the confidence level. So X, 647, and N is 1043, and our confidence level is, I'm hearing some interesting sounds over there. It just makes me wonder what's going on. Press enter and boom, we should come up with 0.5909 and 0.6498. So a federal court report indicates that 27% of children ages 2 to 5 years had a good diet, an increase over previous years. How large of a sample is needed to estimate the true proportion of children with good diets within 2% with 95% confidence? So this is a question that is asking us to compute a sample size so that when we compute our confidence interval, the width of our interval is going to be no more than 2%. Now remember, when we were talking about confidence intervals the last time, this is how wide you want your interval to be. So now the question is what sample size do you need so that you have your p hat, and then you can go plus or minus 2%, and within that plus or minus 2%, you're guaranteed 95% confidence. Okay? So this is a sample size computation. So remember that when we were forming our sample sizes, it's always in the form of our estimator. Can I spell today? Estimator plus or minus our margin of error. So notice that it's this 2% is what we want this error to be. So we want to go estimator plus or minus 0.2. That's what we want to have 95% accuracy. So we need, and since we're dealing with proportions, remember this is going to be p hat plus or minus z alpha over 2 times the square root of p hat 1 minus p hat divided by n. So remember this is this. So we've got to take this thing in the box and set that equal to our error, because that's what it is. So that's what we'll do. So our error is going to equal to this, and then take the square root, split it in half, multiply over by n, divide by e, and then square both sides. So our sample size n is going to equal to this guy right here. So this is the sample size. When we do this computation, this is the size we'll need to go out and do a poll with. And let's not forget that we need to round up to nearest integer. So flipping back to this guy, let's do our sample size computation here. So we know that sample size n is going to equal to the z alpha over 2 squared, and then it's going to be p hat 1 minus p hat divided by the error squared. So for a 95% confidence interval, we know that z alpha over 2 from previous work is 1.96 squared. P hat, well, that's the proportion that was used a few years ago, so we'll put in 0.27, and then it's 1 minus p hat, so 1 minus 0.27, and all this is going to be divided by 0.02 squared. So again, if we just go, however you want to type this in, so 1.96 squared, open bracket, 0.27, close, open, 1 minus 0.27, close, divided by 0.02 squared. Just type it in how you see it. Press the magic button. And since we have a decimal answer, we know we're going to round up to the next integer. So that means in order for us to get 95% confidence and have an error of 0.02, then we need to go out and sample 1,893. So n is 1,893.